Okay, kids, we are looking at lesson 5 today, which I believe is on page 43. So go ahead and find that page and get ready to go. So we are continuing our work with fractions and adding and subtracting fractions. And part of adding and subtracting fractions is understanding really what a fraction is and being able to mentally estimate. So when we look at a fraction, I should be able to say, is that close to almost nothing? Is it close to half? Is it close to almost a whole? So if I look at a fraction like 3/8, right, I can think about if I have 8 of something and I have 4 of them, that's close to half. So I could say that 3/8 is close to half. And then if I take about a half and I add a fourth to it, that I am going to end up with something that is less than 1. So kind of using that mental thinking it through to estimate. Let's look at our next one. So I have something that is 5/9. So I'm thinking that's kind of almost about half of that. And 2/3 is a little more than half. And then 2/3 is a little more than half. So if they're both more than half, then more than half plus more than half is going to be a little more than 1. So I think it's going to be between 1 and 2. Going to this one, it's subtraction. So if I'm starting with a fraction that is less than 1, like 3/4 is less than 1, and I'm taking some away from it, I'm still going to have something that is less than 1. And our last one, I have 10/15, so I should be able to look at that. And because I see that the top or the numerator is greater than the denominator, I should know automatically that that fraction means more than 1. I could even do my in and out mentally and think to myself, well, that's basically 1.5. So 1.5 minus about 1, because 4/5 is almost 1, is going to be somewhere between, is that going to be less than 1? Is it going to be between 1 and 2? I think it's going to be less than 1. Okay, let's take a look over on the back side. The next page, which is page 44. So we were using the tape diagrams to help us as we add and subtract fractions. Remembering that in order to add and subtract fractions, we have to have what you call like units. Both the denominators have to be the same in order to add them. So they have to be the same size, same shape. So let's take a look at this very first one and see what they have us doing. They have us doing 1/2 plus 1/4, okay? And they're showing us this tape diagram. Now, what is interesting about this tape diagram is they are showing half, but let's count the pieces. 1, 2, 3, 4. So they already have a tape diagram that's showing fourths. And they're showing us here that 1/2 is the same as 2/4. So it's kind of like they've already done the work for us here, okay? So now, because we know that 1/2 is the same as 2/4, we can actually add them together and do our work, right? So let's go ahead and do that. So we know that 1/2 is the same as 2/4 plus 1/4 is going to give us 3/4. Okay, so our answer is 3/4. Let's take a look at the next one. This one, again, they're showing us 1/2 minus 3/8. So we need to change halves to eighths. And remember that we're kind of also showing, even though we're just using this tape diagram, we could also think about this as by multiplying to find this new. So if I want to change halves to eighths, we could ask ourselves, what do I have to multiply by to make eighths? So hopefully you're saying 4. And so we can multiply the numerator and the denominator by 4, and we can see that 1/2 means the same as 4/8. So what that means is I have to take this and I have to change it to eighths So to do that, I'm going to cut this in half, and then cut this in half, and cut that in half. Cut this in half, cut this in half, cut this in half. So now I'll have 8s. 1, 2, 3, 4, 5, 6, 7, 8. So I can say that 1/2 is the same as 4/8. And I can say 4/8 minus 3/8 is going to equal 1/8. So again, we're trying to find the fraction equivalent for 1/2, which is 4/8, but we need it to be in the 8ths family. Okay, let's go down and look at this next one. So I have 4/9 and 1/3. Again, they're giving us related terms. Remember how they said they were going to give us related fractions? We have thirds and we have ninths, and those are related because you can think of fact families. So I can change thirds by to 9 by multiplying by 3. I want you to kind of see that we're doing 3/9. So essentially we are doing this. We're cutting these into ninths to find their fraction equivalent. So 1/3 is the same as 3/9. But eventually we're going to get rid of this fraction bar, and we're going to use that multiplication method. So that's why I keep showing you that. So I just say to myself, thirds, how can I change a 3 to a 9 using multiplication? So we now can say 4/9 plus, not 1/3, but plus 3/9 equals 7/9. Okay, so coming over here, looking again, I have tenths, I have fifths. I'm thinking to myself, I can change my fifths. So let's go down here first of all, and we're going to show fifths. So cutting this into fifths, which I'm not very good at, but let's give it a try. 1, 2, 3, 4. Well, not too bad. Not the best, but okay. So I have fifths, and I am shading in how many fifths? I'm shading in 2/5. And then I'm going to label that because this is showing that this is 2/5. So bad at brackets. And so then I'm asking to myself, how can I change fifths to tenths? Well, that would be like cutting each of these in half, which we know is multiplying by 2. So now I have 4/10. So let's see if that's true. I cut this in half, I cut this in half, cut these all to make tenths. And do I have 4 out of the 10? I do. So 2/5 means the same as 4/10. Okay, so up here I could say 7/10, and instead of fifths, we're going to use tenths. 4/10. So 7/10 minus 4/10 is 3/10. Okay, so again, finding a fraction equivalent for these unlike terms or unlike units, we need them to be like units. Okay, let's go to our next page, which is this one, page 45. Okay, so now they're not going to actually provide us with a model. We have to actually do our own job of creating a model. So we have 3/4 plus 5/12. So I'm thinking to myself, okay, I can change fourths to 12ths. So we can draw this model down here. So we're going to draw fourths. So let's draw our fraction bar here, or tape diagram, and we're going to cut it into fourths. So I like to cut it in half first, then cut those in half, and then we're going to shade in the amount we have, which is 3/4. So I have 3/4. We're going to label it. Hopefully you're better with brackets than Mrs. Shaver is. That is 3/4. Okay, so now what we're asking ourselves is we need it to be 12ths. So we're trying to change fourths to twelfths. So again, I like to show you the multiplication because eventually that's where we're headed. What can I multiply times 4 to give me 12? Okay, so if you're saying 3, you're correct. Whatever I do to the denominator, I do to the numerator. So 3 times 3 is 9. So let's look and see if that's true. If I come up here and I change my fourths into twelfths, and I multiplied by 3, so notice each piece is going to be cut into thirds. So this gets cut here, this gets cut here, 3 pieces for here, and 3 pieces for here. So now I have 12 pieces. I should have 9. Let's count. 1, 2, 3, 4, 5, 6, 7, 8, 9. Yes. So 3/4 is the same as 9/12. And I could label it up here, but I'm not going to because I already have it labeled here. All right, so let's use our 12ths now. So instead of 3/4, we're using 9/12. 9/12 is our fraction equivalent. 9/12 plus 5/12 is going to give us 14/12. Okay, 14/12. Now, this is an improper fraction. We're not quite there yet, but I do want you to know that we will never usually leave these as improper. We will do the in and out method to find out what the actual equivalent is. So if we were to do that, just to do it right now, 1, right? And we subtract, and we have 2 left over, and we make that into our fraction, 12ths. So 14/12 means the same as 1 2/12. Okay, so that's where eventually we're headed, that direction, where you're going to be able to do those steps and we'll be proficient at it. Let's move down here. Okay, but today our focus is using the model. So I have 11/12, I have 2 6. So I'm going to be changing 6 to 12. So let's draw our model. Let's cut it into 6 pieces. So let's see, I'll cut it in half and then cut those into thirds. Really not very good at the drawing today. Okay, then we have 2 6. So shade in 2 pieces. And let's label it as 2 6. Okay, so now I need to change my 6 to 12ths. So what could I multiply times 6 to equal 12ths? And if you're saying 2, you're correct. So 2 times 6 is 12, and 2 times 2 is 4. So we have 4/12. So that would mean we're cutting these. Nice sound effects, huh? Into 12ths, and we can see that 2 6 means the same as 4/12. So we could label this up here. I know we didn't do it last time, but 4/12. Okay, so we're going to use 4/12 instead of the 2 6. So 11/12 minus 4/12 equals 7/12. Okay, and then our last one here on this page. Let's look at this last one. I have 9ths and I have thirds. So we're going to be changing our thirds to 9ths. So let's go ahead and draw our picture. And I have thirds. And I have 2/3. Shading in my 2/3. And labeling it. And then we're asking ourselves, how could I change thirds into 9ths? What could I multiply by to change thirds into 9ths? So if you're saying 3, you are correct. Okay, so that would mean I have to change this into 9ths. So this gets 3 pieces, 3 pieces, and this gets 3 pieces. So now I have 9ths, and let's see if it's true that 6/9 is the same as 2/3. 1, 2, 3, 4, 5, 6/9 is the same as 2/3. Okay, so we're going to use that in our equation up here. 7/9 plus 6/9 equals 13/9. Again, if I have one of these, we are not going to keep it improper. We're going to do our in and out method to find what it equals. So 13 divided by 9 is 1. And then we subtract, and I get 4. And I take that 4 and I make it into my numerator, and my 9 is my denominator. So 1 4/9. Okay, nicely done. Let's see what we have in store for us on our very last page. Okay, looking at page 46 up at the top, okay? And it says on this page, 8/5 minus 8/10. And so again, they're actually giving us 8/5, something that means more than 1, okay? And they want us to change it to this time, they want us to do it a little bit different. They actually want us to change the tenths to fifths. Okay, so let's think about this for a minute. Let's draw. This would be using division this time. So let's draw our picture of our tenths. Let's draw our fraction bar. Let's see, I think the easiest is going to be to cut it in half first, and then maybe do fifths on this side. Let's see, 4 lines. 1, 2, 3, 4. Not too bad. Let's try it on this side. 1, 2, 3, 4. Okay, I should have 10. Let's count. Oops, shifted it. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. Okay, so now they're wanting us to shade in 8 out of 10 pieces. Oops, I just shaded in 9 almost. So let's pretend I didn't shade that part. That's where I ended. Shading in 8 pieces. 1, 2, 3, 4, 5, 6, 7, 8. So we'll put a little bracket here, and they're showing us 8/10. Now, they want us to change it to fifths. So let's think about that for a minute. If I was going to change this to fifths, I can't use multiplication, but I'm going to be using instead division. So I could divide by 2, divide by 2. Okay, so on the top, this would become 4. So look at what we're really doing. When I divide that 2, just like when I multiplied by 2, it was cutting each piece in half. When I divide by 2, it's almost like gluing 2 pieces together. Let's look at that. So it's like taking these 2 pieces and gluing it together to make a bigger piece, gluing together these 2 pieces, gluing together these 2 pieces, and gluing together these 2 pieces. So can you see that that's 1, 2, 3, 4? So 4/5 is the same as 8/10. So now we can use that fraction in place of our 8/10. So instead of saying 8/5 minus 8/10, we can say 8/5 minus 4/5. And then we will get 4/5 as our answer. Okay, so they threw a little curveball at you, a little tricky one for the very last one. Okay, let's look at this one as our very last one. Okay, it says use the read, draw, write method to solve the problem. Noah draws a line 13/16 inches long. He erases 3/8 inch from the line. How many inches long is the line now? So if he's erasing inches, that's telling me he is doing what? He's subtracting or taking it away. So we have this problem, 13/16 minus 3/8, right? So if I'm like thinking about this, And if I was drawing a line or something, I could almost be like, okay, the line is 13/16 long, and then he erases part of it. If I'm picturing that in my mind, like draw a line, erases part of it. Okay, so I'm doing this as my math. So what am I gonna do? I can't subtract unless I have like units, and I have 16ths and eighths. So if you're saying to yourself, well, you could change eighths to 16ths, I agree with you. So we could do this. We could say 13/16 minus, and then we could do this, 3/8. To change 3/8 to 16ths, I could multiply by 2. Right? And so now I would have 13/16 minus 3 times 2 is 6, and 8 times 2 is 16. So now I could do that math. So what would 13/16 minus 6/16 be? So hopefully you are saying 7/16. Okay, and so it's a word problem, so let's answer with a word sentence. The line is 7/16 inches long. Okay, there you go. Good job.